Hi everyone, good morning. Thanks for joining us on a Sunday morning to do something interesting and having a learning exercise. We are going to make sure that this is going to be a time worth investing. So, what we are going to look at today is going to be an interesting case study. And this is around Amazon Prime dataset. So, you must be familiar with the OTT platforms such as Amazon Prime, Hotstar, and the other ones. Today, we're going to look at movies and TV shows from Amazon Prime, what insights we can get out of it, and we are also going to see how they make recommendations when users search for something. So when you're searching for a movie, something maybe related to World War, something related to horror, how do they come up with those suggestions, and what's the best way to do it? We're going to explore a few of those interesting things. I'll also be explaining some of the code in the process. But again, at this point of time, it's good for you to understand the flow, what insights we get, how do we think about it, rather than how exactly the code is. We are going to look at the code in Python programming language. This is quite easy and straightforward and very easy programming language to learn. If you know English language, you just have to try a little more harder to also learn Python. It's quite easy if you, as long as you can think in a very structured way. So on that note, we are going to start. There are a couple of cells. I'm not going to go into very minute details about it. So what I want to say is, before we start coding, we need to do some imports, which is what we are doing in this cell, and then we need to do some installations. Okay. So what are we importing? What are we installing? So uh, let's say if you want to hang a painting on a wall, right? Uh, what kind of things would you need? You would need a painting, drill machine to drill a hole, and then a screw and a screwdriver, right? But when you are actually going to go for the task, you are not going to build your own screwdriver or you build your own drill machine, right? Maybe you can make your own painting, which is what we are going to do at the rest of the notebook. But you're not going to actually, as a frame, process build that, because those tools are already available for you to use, right? So when we are importing and installing libraries, those are tools that other developers have made available, or organizations, which we can use for our code, and we do not have to invent everything from scratch. That's what libraries are. These are like screwdrivers and drill machines, tools to do something in an optimized way without having to do it from scratch. So with taking a set of tools, you can uh, hang a painting, build a table, lot of different things, right? So that's what it is about. So import is for things which I already have in my system. Think of it like I already have the drill machine in my garage. I just need to take it out for my task, right? So you need to go somewhere, bring it out, right? You already have it. But installation is for things that you do not already have with you. Let's say you do not have a screwdriver at your house. You need to go out and purchase it. You cannot take it out of your garage, right? So things you do not already have in your environment or system, you would need to do installation on that. And things you already have installed, which is at your, let's say at your home, you just need to take it out to do the task. That's what we do with imports. Now, why do you import only a specific set of libraries and not all? Just to keep the memory and the processing efficient, and that's about it. So we take out only things which are necessary for us. So given that, on that note, we are going to start diving into the data set itself and what is the uh, like what insights can we get out of it. So once we do some installation here, right, we are going to get import some of those libraries which are also going to be useful for us. So first, installation, then the imports of relevant things. These things we could import before because we already have them installed. Okay. Now we're going to dive into the data itself. So like I said, data is Amazon Prime titles, and this includes both movies and TV shows, right? And how does the data set look like? So I have an ID like any data. So think of this. So data can be in many different shapes and forms. You can have video, you can have images, you can have audio, you can have text data set. This is a text data set, but also in a table form. Okay. And table form is like, if you're familiar with Excel, is just or SQL tables, it is like a tabular format structure where there's some rows and some columns. Columns are the attributes of a certain thing. Rows are instances of something. For example, each row here is a movie, right? And that movie has a title, has a director, cast, country where that movie released, the date when added and released. Uh, Sorry, the date when this is the date when it's added to the Amazon Prime list, and the release year of the movie, rating of the movie, and this rating is like whether it's safe for children to watch, what age is good, and things like that, right? And listed it is like genre, and description is a description of the movie. So this is what the data set looks like, and we're going to deep dive into it. So before we go deeper, just want to check, do you have any questions? And if you have any questions, feel free to drop it on chat. I'll check it from time to time, and that should be good. All right. I don't see any questions, but if you do have anything while I'm going through it, feel free to ask. Okay. All right. So I do some basic exploration of the data set after I take a look at it. So the way I take a look at it is something like df.head. It's a standard command that you can use to do. Before that, I'm loading the data set by stating the name of the data set. And this is how my data set looks like. Now I'm going to explore the data set a bit more. So what I'm going to look at next is the shape of the data set. What this means is the first value is the number of rows. So these are the number of movies and TV shows that are present in the data set. So 9,668 movies and TV shows I have in my data set. 12 is the number of attributes or the columns, right? What you see here. So for a movie or a TV show, what is the title, director, cast, country, like that we have 12 attributes or 12 columns, right? So there's one way to look at the shape or the number of rows and the columns that we have. But if we want to look at some more details about them, all right, we still see this many entries, which is TV show and movies. And for the columns, now I have some visibility into if they have missing values or not and what kind of data type is there. So data type will tell you either it's an integer, which is like a number, or float value, which is like a number with a decimal place. Object can be anything, and most of the time it is text data. All right. So anything which is not a number. Sometimes it will also be a number, but if it kept in a single or a double quote, many times that happen from when you're loading a data set, translating it from someone. Numbers would be hidden as objects or strings, which is text data, and we just have to convert that, get it into the right shape. But this one interesting thing here to look at is I have total number of rows as 9,668. Some of them have that many non-null values, right? But some of them have much lesser non-null values. What does it mean? That just means that some of the columns have missing values. You can see in rating itself. Rating has this 13 plus rating is there for this movie, Take Care, Good Night, which is looks like a Hindi movie, and it's missing for rest of the things that we are seeing, right? So that is you know problem when you have missing information. So let's say I give you a book to read, and the book does not have a few pages, you will not be able to learn well. So you need to have all the information available to learn a subject well, and the book needs to have all the pages. So what do we do with missing information in data set, right? We need to handle it. Uh, One primary reason to handle it is because when there is no data, it will be filled by uh, null values. And machine learning models are not able to process null values. Okay, so that is one of the primary reasons we want to handle it. The secondary reason is that null values do not have any information. Can we bring in some useful information based on the data itself and make it work, right? So that's what we're going to do. But before that, we are going to look at the percentage of null values that are present in each column. So this is the way to do it. So first the data, which is defined with the name df. We did it before, where we loaded it and stored it in a variable called df. Okay, variable is nothing but think of it like a placeholder for storing something. It can store any kind of number, string, data frame, any kind of uh, data structure. Okay. So df, to df, I'm doing a check if df has null values. Okay. So if it does have null values, this check is going to return true or false. Okay. And based on the true and false, I can do a sum on that. So whenever I operate this sum function, what's going to happen is it's going to sum all the true values. That means if out of 10 rows, 7 are non-null, is going whenever I apply this function or this set of operations is going to return 7. If 7 are non-null out of 10, this is going to return 7. Then I'm calculating the length of the data frame. That means total number of rows. So if 7 are non-null out of 10, this is going to give me 7 by 10. It's a fraction, which is why I'm multiplying by 100 to get to a percentage number. And nprout is just a helper function which makes us or keeps our value to 4 digits. Okay. So by doing this operation, we can see all the columns have or some of the columns have a lot of missing values, like country data red has very close to it being 100, but it's some of the values are there, but most of it is missing. Some of the values also have 100% non-null values like show id, type, title, and so on, right? So it's a good insight to have what columns are high quality, what columns are not. So we need to handle, like I said, we need to handle it. So the way we are going to handle it is, so we're going to take a logical approach on handling it. For example, director, cast, date added, and rating. These 4 columns, I cannot logically figure out who's the director, cast, date added, or rating is. Okay. Mm, and because of that, we are going to replace missing values with the term unknown. So this is not null. This is a text saying here the director is unknown, the cast is unknown, the date address is unknown, right? So this is a replacement for null values because null values has a very its own structure, and that if you throw to a machine learning model, it's going to give you an error. So because of that, we need to replace with a text saying unknown or null. That is also fine. But this is a text which does the replacement with the null values. All right. And this is just way to do it. I am defining the columns on the data frame to which I'm going to fill the null values, and what value do I need to fill it with? It's unknown. So the structure of the code is very straightforward. Okay. And then I'm going to save it back to the columns in the data frame. Okay. Any questions so far? No? Okay. Like I said, keep asking questions as we go based on what you get. So what do we do with, the country column? So we did it for 1, 2, 3, 4. So how many null columns do we have? 1, 2, 3, 4, 5. Total of 5, right? We imputed 4 already with unknown. For the country one, we can, do an interesting thing, right? So what we are going to do is, so we're going to see in exploration later, but most of the movies, I'm telling you beforehand, most of the movies you're going to see, let me see if I can show you that plot, but most of the movie that you're going to see is coming from one single country. Hang on. If I show you that plot, it will make more sense. I can't, we'll see it later. But most of the movies are coming from US, right? Based on what we figured out from the data set, right? So that is the most frequently occurring country. Just a moment, I'll just get back to where I was. Yeah. So the way to figure out that was the US, but we are not hard coding it because things are going to, based on the data set, things might change. Here we figured out it's US. In some other data set, when we are working on a similar problem, it can be something else. Do you want to manually check it and do it? No, right? There's a better way. So there is a class that we're going to use, which is called simple imputer. Through it, you can replace a null value of a column with the most frequent class. For the country, in this data set, it's US, right? For some other data set, it would be something else. So why do we do this for the country is because the number of the distribution of the countries is so heavily tipped towards US that for the missing values, which is only or for the country which is very high, uh, it is likely that the other ones are also, what do you call it, US. So there are different replacement techniques for different kinds of data. When it comes to categorical data, category is something like high, medium, low, different countries, and so on. For these kind of things, you can either impute with unknown or impute with the most frequently occurring uh, uh, class or category, right? For this case, we are doing that as a system, so it's going to do it with US, and that's what it is, right? So, and choice of that can vary depending on depending factors. Now, once we have done all the replacement, we want to check once again if the replacement worked fine and if there are any more missing values. So we're running the same command that we ran before to check the number of percentage of missing values. We're running it again to check our replacements are all good. So this shows that no more missing values are there and that is all good. Okay. Uh, Okay. Just one thing I want to say, I mentioned this, that when I'm doing df.isNA, so this is checking for if there are null values in df and only then it is returning true. Not true when there is value in the column. So it returns true only when there is null value in the column and then it does sum on those trues. So that is what I wanted to, explain once again. Now, once I've done the replacement, let's move on to the next step, which is, look at the data frame, right? Now, with that data frame, previously you were seeing this NaN values, which is the null values, right? And this is not something like we discussed, a machine learning model can handle, but those are now replaced with something called unknown for date added column. For the country, you would see a lot of United States because now that we have imputed missing values with the United States or most frequently occurring country. Director also you'll see a lot of unknowns. So wherever there's it's not a country and has missing values, there will be a lot of unknowns where they were missing values. Okay. Now we are going to see what is the distribution between movie and TV shows, right? Uh, so we are going to use something called value counts, and that is a function that we use on the data frame. So when we do normalize equals false, it takes the absolute count or the number of movies and the number of TV shows. Okay. So what it is going to do is look at the total number of movies there in the data set, total number of TV shows. It's clear that the number of movies are much more dominating the entire data set than the TV shows itself. Okay. And this is the function that I use to look at the distribution, some parameters I set, right? Once I've got those values, this is the text for me to plot the distribution of movie and TV show. And there's some ways I can set the x-axis, y-axis, and x-axis is the type of the movie or TV show, or x-axis is a type of the item, which is either movie or TV show. Y-axis is the number of times, you know, or number of movies or TV shows that are present. And I'm using a bar plot. So these are bar graphs. So it's like nothing. It's like it's a count of the number of items. So that's what it is. And I'm plotting that, some setting some parameters and so on. From now on, I won't explain the plot. So this is how usually the structure would look like. Now let's take a look at the directors. And directors also had a lot of missing values. So I would have a lot of unknowns. But apart from that, looks like Mark Knight is very frequently occurring director and so on. I mean, these are ways to explore different columns and figure out some insights from it. So I'm using the value counts again. So this was again gives the distribution. The reason I got the plot here is because after I did the value counts, I did a plotting here. Right here, I'm just looking at value counts, which is a number of times some particular category has occurred. Then this time we are looking at director. Mark Knight is the most common director across, all of them. Now, if I want to know the distribution of unknown across TV and movie show, so I'm filtering for director equals unknown. So this gives me, so for director, when the director is unknown, give me the data frame. This is the filtering criteria. And there I'm doing a distribution of the type, right? So whenever the director is unknown, I'm looking at, distribution between TV show and movie. So it shows, and this is a fraction instead of absolute number, because I'm giving normalize equals true. Normalize kind of makes it like a percentage distribution. So multiply it by 100 is fraction distribution. If I multiply by 100, I'm going to get the absolute percentages. So 89% of the TV show has director unknown, 10% of the movies have director unknown, or that's not the right language actually. The right language is, out of all the unknowns, 89% of them are in TV show, 10% of them are in movie. Okay, so unknown is heavily biased towards, or unknown director. So I do not know the director. So what the insight is, I do not know the directors more frequently in TV shows than movies. Okay. Now what else can we find out next? So now we can find out. So for TV shows, again I'm using the filtering criteria. df.type equals TV show. So for TV show, within the data frame, there is filtering on the data frame. So for the TV show, what is the distribution of director? Again, I'm using value counts, which is for distribution. Using normalize equals true, it gives me fraction term, multiply by 100, that gives me the percentage. So out of the TV show, what is the distribution of director? Looks like all of them are unknown. So I do not know about any directors in the TV show. That's what it means. Okay, so this column is pretty much meaningless for TV shows. So it's a good thing that we found out early. Now let's take a look at the ratings, and we are going to keep using similar functions, which is value counts, that gives the distribution of ratings. And we are again going to use the same plotting library, just that so this comes from something called matplotlib, and we are going to use some of the parameters to set title, X label, Y label, and so on, to represent the plot well. But this is again a distribution plot, which tells us 13 plus 16 plus are the ones that are dominating the entire rating category. But then I did not do any filtering, right? So it's combined with movies and uh, TV shows. And there, if we go down the path, we actually don't see anything. But if we explore a bit more on Um, that is also something that we'll do later. If we explore a bit more on the ratings, yeah, we actually see it here as well. So TV has some of their own tag rating, right? Movies have 13 plus, 16 plus. TV has TV 14, TV PG, TVNR, right? So they probably have the same categories. And this tells me maybe it's a good idea to do look at the distribution of ratings separately with movies and TV shows, right? Now that's what we're going to do. So we are now going to look at the distribution of rating, uh, but segregated by movie and TV show. So we are still we're using value counts for looking at the distribution, but now we are segregating and looking at the distribution of rating, but now we are doing segregation with, hue, which is using the type. Type is nothing but movie and TV show. All right. So for movies and TV shows, both of them have 13 plus, 16 plus. All these ratings are dominating it. But you see some rating like TV 14, TV PG, TVNR, there are no movies around it. There are only ratings for TVs only, right? And there's some more rating here, which are dominated only by TV. So that's an interesting insight in terms of the rating itself. All right. Now we are going to go into genres and what kind of movies there are: comedy, drama, documentary, and so on. Right? We are going to take a look at it. Do you have any questions so far? Anything? Okay, so I think there's a question from Shrikant saying, is data frame in memory? Yes, that's right. So we're loading it into memory, and that's how we are going to operate. So we're loading it from the disk, hard disk, or local desktop. Yeah, that's still hard disk. It can be on cloud also. But for this particular thing, we are loading into a thing called Collab. It's an open source, or not exactly open source, but provided by Google. It's free to use. You can use it for your data science exploration. That's what we are using for today's session. But the data frame is loaded into memory. So how do you fill integer or date null with unknown? Okay, it's a good question. So for integer, there are many different ways to do it, and the common ones that you will see is mean, median, mode. Okay. Uh, there's also a thing called interpolation. Uh, there's interval imputer. Lot of different complex strategies. So what is the most common way to do the replacement of missing integer is mean, right? But there are some issues with mean. The issues are that if there are outliers, like very large values. So if you take the average, let's say I'm looking at the salary data set, and some folks have $1 million salary, but most of the average without that $1 million is around, let's say, 100,000 USD, right? But those $1 million salaries would probably push your average towards 300,000. But that's actually not the average salary of any person. So median, exactly. Median is a good way to do the replacement. But the problem is that sometimes the missing values will be too much. Then median will skew your entire distribution. Okay. But median is a good default. Some more complex strategies like interpolation or KNN imputer, where, for example, when there's, let's take the salary itself, right? For example, I work for Microsoft, and if you take average salary of, and I'm senior data scientist for Microsoft. If you take 5 senior data scientists and take their average salary in Microsoft, you will be closer to my salary also, right? So KNN Imputer is taking similar data points and replacing it with the average of those data points. So a lot of different strategies are there. Median is a good default. You will use something more complex like KNN Imputer and interpolation as more complex strategies. For date values, again, most commonly occurring date is a good one. Rather than, uh, what do you call it? Yeah, so for date value, the most commonly occurring date, or sometimes, again, based on KN imputation, you might figure out what date can be closer to a particular date point, but most of the time you do a mode on this for the date value, or maybe use something like unknown. But then if you have to do some operation, that becomes a problem. Date is a little more complex and it depends on the data set itself. Sometimes you might want to set it to start date, end date, some date which is out of range. You can do a lot of things, but it totally is data set dependent, which is why it's not a straightforward thing to answer. The other question is, what about mode? Yes, mode is a good option also, but it depends. You would more mainly do it for categorical data instead of doing it for any numeric data. So mode is good for categorical data when you have high, medium, low, and movies and categories like that. Country. So is Kane and Impute the best one? It's one of the good ones, simpler to use, and but I wouldn't say there is any best separately. Like I said, it depends on the context, data set, and a lot of things like that. So you would need to, and the depth of it is very difficult to cover within this short span of time. But there are many different scenarios to look at, where in which scenarios what is good. But K&N imputer is a good one. It should work well most of the time. But some of the time, based on the data set, something like median or mean can also do very well. Then you would want to simplify it and do that only. K&N imputer might be a little more complex, right, to maintain and handle. So there is a best one. It depends on the context and the data set. So does data frame handle data that is too large to fit in memory? It does, but it depends again on the data set. If it's too large, data set itself is too large to fit into memory, then it's not going to work out. If data set is large enough, fits into memory, but if it's very large, like takes up 50% of the memory, then what is going to happen is, if you're going to do complex operations or building a model on it, it might run out of memory and crash. So what you might need to look at is either look at having bigger resources like bigger memory, bigger GPU, and things like that, or you might need to use some other platforms such as PySpark, which can handle big data, right? So there are different platforms you can move to. But again, you might think of it as learning something new. But if you know Python, you can also do coding in PySpark. So that should work out fine. Okay, for numerical order data, can we go for label imputer otherwise, or go for one-hot encoder? Yes, that's a good option. So I'll give you a couple of things which are also even better. So the problem with one-hot encoder, it's a good default. I would definitely say if you have 3, 4 categories, do one-hot encoding. That is very good. But the problem with one-hot encoder is, if you have a very big data set and you have a lot of categories, like 1,000 categories, so that one hot encoder is going to create 1,000 columns, right? And most of that data is going to be sparse. That is because one hot encoding is one and zeros, and those most of the time those columns will be filled with zeros, because if one category is occurring, the other ones are most likely not occurring, right? So it means the sparse and the zero problem is, most of that part of the data frame does not contain any information but takes up a lot of memory, right? In those cases, one hot encoding is not going to be good. So what is going to be good in that scenario is something called as embeddings. Embeddings is, instead of saying in one hot encoding, what happens is we have one on zero, which is whether that category exists or not. But for embeddings, instead of saying that category exists or not, we are going to figure out some meaningful representation of those categories, but in less number of columns. So we can define for embeddings, we are going to have, let's say, 10 or 100 columns. Within those 100 columns, all the categories will be represented, and these embeddings would have continuous number. And what that also means, by experiment, we have figured out, by we, I mean the entire data science community, that if you plot the embeddings, uh, it has a lot of meaning associated with it. For example, king and queen will be close to each other in those embedding space. Man and woman is also going to be close to that embedding space because those are humans. But there will also be difference because of the difference in gender. And man and woman block versus the king and queen block will also have differences because one is royalty, the other is not. So there are also a lot of these interesting associations when you use embedding. So for categorical data, numerical data, embedding is the state of the art. But for simple problems, when you have less number of categories, use not encoding. So that's the right answer. In that case, can we L1 use L1 regularization? Uh, that's an interesting way to think about it because L1 regularization definitely does elimination of unwanted variables, but it wouldn't also be the best way to do it. Because there are better options available. Like when you have too many categories, use embeddings. Embeddings is a better way to do it than going to the L1 regularization route. Use L1 regularization for all other kinds of data, not too many categories. Embeddings being dense vectors, yes. So you will have a fixed set of length that will be defined by you, and it will have information for each category. Embeddings are more commonly used in text data, where let's say I any machine learning model is not able to process, or computers are not able to process anything apart from numbers. So text has to be represented in numbers, which is one of the way we do why we do one-hot encoding and why we do embeddings. Uh, so the advantage of embedding, or it is commonly used in text data, is so when I say you have to train or learn your own embeddings on text data, many of the times you are going to also have existing models which are trained on English language whose embedding you can use. What I mean by that is you don't have to train your own embedding. A lot of open source libraries which you can use to just use for your use case, not train any embedding. Just call the embeddings and use it on your data set. That's what it is. So is it sentence transformer and embedding? Yes, embeddings can be at various different levels. It can be word embedding, it can be sentence embedding, it can be paragraph embedding. It depends on the again use case and what you want to use. We are actually going to use a sentence embedding model today at the end of the notebook. All right, pretty good. So I guess I've answered all of your questions. Let me know if I have not. We'll move on with the notebook. So good to see these questions, right? It makes me understand that you already have some prior knowledge. You already have some idea about how to process this data. So that's good. I wouldn't actually then go too deep into explaining very basic coding stuff. We'll again catch the flow of our analysis and explain some code whenever necessary, but I won't repeat the basic stuff then. Okay, coming back to exploring the genres, right? So again, if we look at the distribution of genres, we are going to then see, we are again using value counts to look at distribution. So that's the standard for us. And we are going to segregate using the type, which is movies and TV shows, and looking at the genres across movies and TV shows. So look like drama is the most common across movie. TV show, it's TV show. It just means the genre is not defined. Some TV show. Now you're gonna see some genres have multiple genres within it, and that is not something we want to. It's not easy to see or understand, right? So what we are going to do is, and there is something called arts, entertainment, culture, comedy, and special interest. Right? And looks like there's significant amount of that is there. But for rest of the stuff, what we're going to do is whatever there's like multiple genres in one genre combined, we are going to split it up so that we can see separately how many comedy, drama, documentary, special interest, instead of being combined as into one category, right? So the way we split a string is by using at the end of the string using a function called split, and we're going to use the identifier for the split. Here for our genres, between two genres there is a comma. So we're going to split on the comma. Okay, that's what we are doing, splitting on comma, and that gives us two separate genres in two separate, list. So this is a data frame called list, or data structure called list, which holds a list of anything. It can be list of anything, but here, because it's a string we are splitting, it's a list of two categories, which is two strings, which are two genres. Okay. So for one specific this arts, entertainment, and culture, so we are using this as a special category. So based on the exploration, and we don't have time to go into detail of everything, but based on the exploration, we see arts, entertainment, culture as a genre has been, what do you call it, being a special category in itself. So we want to segregate that as a special category, and then and not split that up, and then everything else we are going to split it up. So that's what we are doing. We are segregating that as a special category by applying. So apply is a way to apply a function on a data frame on a particular column, which is the listed in. This contains a genre, and then we are searching for this and creating a separate category out of it. Let's see, do we have anything here? No. Okay, but for the other ones, what we are doing is still applying the you applying a function on this column listed in, and you would say, see that there are two ways I can refer to this column. Here I referred it by using df.listed in. Here I am referring to at bracket and single quotes. Both are same, both are going to give you the same results. On that you can apply a function. Here I'm applying the function x.split. Okay. X is, so what it's going to do is for every single value that is here in the column, it's going to apply a function. So what it applies is split, which is what we saw for every this. We're going to split on comma. For the single ones like the kids and TV shows, it does not have comma, right? So they're going to remain as it is. They're not going to be split. So I'm splitting on comma, and then I'm also stripping it of extra space. The reason I'm doing it is, see, when I do the split here, suspense has that extra space attached to it. We want to remove it, which is why we are doing the strip. Now, if you see, I've created the genres, which has now the list of uh, genres in it, right? How is this different from listed in? So this is a string, and this string representation is like an entire name. From there, I do not have a segregation of saying, or there's no easy way for me to get the comedy or drama out if I want to look at it separately. But when I have a list, I can actually query this list. So when I say, give me the first value of this list, it will give me comedy, second value drama, like that, right? I can't do that in string, which is why I'm converting it to this format. All right, once I've done that, next I'm using multiple label binarizer. This is similar to one hot encoding. The only thing is that every single row can have, so in one hot encoding, every single row is going to have only one column with the value of 1 across that row. Everything else will be 0. For multiple binarizer, because I have multiple categories like comedy and drama within the single row or within the single movie, I can have one in more than one in multiple columns. So what this is, this might not seem so for the folks who do not understand one hot encoding, I'll tell you what it is. So let's say I have genres like comedy, drama, and horror. So the moment I have one hot encoding, let's say I have 3 rows, 1, 2, 3. Okay, let's take 5. And then I have, in the first row I have comedy, then I have drama, then horror, then horror. Okay, then if I do one hot encoding, Okay, now if I do one hot encoding, what it is going to do is it's going to create three columns. Okay, comedy, horror, drama, and horror. For the first row, is going to have 0, and then for the rest of it, it will. So the first row is going to have 1, rest of it is going to be 0. For drama, the first one is 0. Second one is 1. Third one is 1. So wherever that value is present is going to have value of 1. Wherever the value is absent is going to have a value of 0. Similarly for horror, it's going to be 0 for first 3. And 1 for the next 2, last 2. Okay, so what hot encoding does is, like I said, computers cannot understand text and we have to convert it to numbers, which is why we are doing it here. So one-hot encoding will make these categories into numbers. What is going to create is 3 columns, and then is going to replace whenever that category is present in that row. So for the first row, comedy is only present, so comedy is going to be 1, rest is going to be 0. Second and third, drama is present, so drama is going to be 1 and 1 there, and rest is 0. For the fourth and fifth, only horror is present, so that is going to be 1 and it's going to be 0, 0. Okay. The difference with multiple binarizer is now I have multiple categories like comedy, drama, right? Both in, let's say, first row, then both are going to be 1. That is the only difference. Okay, then this is an interesting way to show categories. The other way is embeddings. We are not going to cover that today, but good. Any question? Couple of questions. So for EDA, no need to learn coding steps using different libraries. We're supposed to explore these libraries to get insights pattern in the data, and then take certain decisions on applying further machine learning. Want to know your thoughts? You would need some basic coding because uh, you eventually communicate with the data using code. But you're right, it's not heavy coding. One, the second thing is that once you've done exploration on, let's say, 2 3 data sets, you'll be reusing a lot of code. So it's not that you're writing very new code. You can just copy paste your code from one notebook to the other. For example, like for distribution, I'm using value counts everywhere, right? You just need to give the name of the column and the data frame, right? So those are the only changes. So the coding, new coding will be minimal. So you're going to repeat a lot of those stuff because we have beautiful libraries that we imported in the beginning. And you're right, we can use something like pandas, and numpy and pandas to do things like that. So yeah, you're right. So these tapes can be referred online resources available like ChatGPT and many more. That is true. The only catch is, how do you know ChatGPT is giving you the right response or not? For that, you need to know data science. You need to do this. You need to know how these things work. And if, let's say, it's giving you, what do you call it, a wrong code, how would you know if there's something wrong with it? So I mean, ChatGPT is definitely something that can help you speed the process. Okay, you can do things faster by without having to write anything from scratch. But you still need to know it, have written it before in the past to know that if ChatGPT is creating the right response. Only then you will be able to optimize. So learning is still very fundamental and important. But ChatGPT can make it let you do it faster only when you have mastered it. Okay. All right. Let's continue. So then I'm looking at the classes that multi-level binarizer is looking at, like action, adventure, animation, interest. So this is more like, uh, all the classes for which the columns are being created. Okay. So if I, now look at it separately. So what I'm going to do is, and this arts, entertainment, and culture, right? This is something that we used for creating a separate category in itself prior to getting the other categories. So for the operation that we actually did here is we removed because we wanted to create a separate category on arts, entertainment, and culture. We removed the commas in art, entertainment, and culture. That's what we did here, so that when we split by comma in the next step on the other genres, it does not get split and remains as a separate category. And that's what happened. Where are we? Yeah, so that's what happened here. And these are the rest of the categories. So now this is to show all the columns that are there in the data frame. Pandas by default is not going to show you all columns and suppress some of them. For example, you see here dot dot dot. So it's not going to, because it takes up memory space and your visual space also. It will suppress unless you tell it to not suppress and show you everything. So you want to show everything is what we are defining here. And then what we do is we get all the columns we just created using multi-level binarizer. Okay. And then we join it to our data frame with some other columns. So what we are doing is we are getting the data frame with these columns only, title, type, listed in, and genres. And then we are doing a concat operation, right? This comes from pandas operation, pandas function. So we are doing a concat operation, which is filtering the data frame on this column. So from the data frame, I'm picking these 4 columns. Then whatever multi-level binarizer data we created here, I'm joining side by side, like adding those columns to the data frame. That's what we are doing. So that creates my genre dataset, which is it has the title, the type of the movie, and the genre before transformation, uh, or genre when it was a list, and then multi-level binarizer. So this is my genre dataset, which I can use later for other things and also do some exploration. So here I am doing exploration in terms of, so I'm filtering by TV show, and within the TV show, I'm doing a value counts to see which is the most commonly occurring genre. Okay. Uh, so here I'm sorting by, what do you call it? All these columns. So four colon. Yeah. So 4 colon means, so 0 is the starting index of any column or row, like we see here. So column 0 is title 1, 2, 3, 4. So 4 column means 4 onward is the all the columns that I'm taking. And then I don't need to do value counts here because it's already in values of 0 and 1. So I need to count. I just need to do a sum to find out the number of, you know, times does a particular category occur. But this time I'm doing it count across the column, or not across the column, down the column, right? So once I'm doing that, I'm doing sort value, ascending equals false. That means I'm doing a descending sort, means highest, the most commonly occurring TV show genre is going to occur first. So that gives me the distribution. The drama, kids, documentary as the most commonly occurring ones. And then sport and anime, science fiction are the ones which are least common. Okay. Now, if I want to do the same thing with movies, the same function again, I can see that drama, comedy, and action are more common across movie. The less common is animation, adventure, and western. Okay. With genres being explored, we are going to come back to it and use it again later. But now let's take a quick exploration with the duration. And like I was saying, duration here, you can see, like I was saying before, that sometimes integers would be, or numbers would be hidden within quotations and represent as strings or text, but it is actually not. Here we can see the duration of the movie is actually in a number form, but hidden into text because it has the mean, or which is the minutes attached with it. Okay. But you can also see see there's something called 2 seasons, 5 seasons, and so on, right? So the unique function gives me the unique number of values. So things which are not repeated, unique values for particular column. Here we are looking at the duration column and all the unique values around it. So because of the values, it does look like main is probably representing movies and these seasons are probably representing TV shows. Okay, so that's what we're going to see and figure out. Right, so we are going to take the duration on which we are going to search on season. So their seasons are in caps. So we are going to apply the function lower. That means everything will be hard. Here we are actually lowering all the seasons. So making sure there is no variability and everything is in lower caps, because a season which is in upper caps versus a season in lower caps, they will be read as separate strings. So first what I'm doing is converting everything to lower caps so that I can search for season. Now I'm searching for season and then creating a new column where if the season is present in the text for the duration column, so duration column has all these values. So whenever the value season is present, so this is string match, like a text match. Think of it this like I'm applying a function, and the apply function is like you can apply any function. So I am searching whether season is present in the text. So it will not be true for 81 minutes because season is not present, but 5 season has season text present in it, right? So it is going to mark those values as true. Rest of the values are going to be false. So I'm creating a separate column by doing this particular operation. So let's see if yeah. So I have this. Let's say this column duration season. So where is my duration? Yeah. So duration has 130 minutes, 130 minutes, 87 minutes. It does not have the word season. So all of them are false. So wherever it would have, let's say, okay, let me try to get more samples to show you if there's more duration to it. Is there any true? There is no true. Okay, fine, no problem. I mean, let's just assume, it has true for whenever there's season, or maybe we can do. Okay, let's get back to it. But uh, this is what this operation does, and this also shows the same thing. Okay, so once I do that, then what I'm going to do is I'm going to plot that for duration season column, which is true whenever this season word is present in duration, or if not is present, I'm looking at the true and false count across both TV and movie shows. So this shows validates that it has worked correctly, because all the true values of season being present in the duration is true for TV shows and false for movies. So that means no season text is present in duration of the movie, and all the season text is present in duration of the TV show. So that season thing is only for TV show. So this is what confirms it. So now like I said, I want to convert the duration into numbers so that I can, do some extra exploration. That's what I'm going to do. I'm going to do the split again. This time I'm doing the split on the identifier mean. I can do it on anything. And then I can, so this is the first index, right? So if I do index of, let's say, 1, it's not going to give me anything. That is because, so let's say it's easier to explain with something else. Let's say I can do split on 0, right? If I do split on 0, the 0th index is going to give me 1, okay, which is on the left hand side. But if I do a split on 0 and ask for 1, it's going to give me min, okay. with space in between. What that means is, so whatever you are splitting with, so let's say I have 10 min, and if you're splitting on 0, so it's going to eliminate 0 and create two index. 0 is the left hand side of 0, sorry, 1 is the left hand side of 0, so that can be referenced by the index 0. On the right hand side, the space of min, so that can be explored by the index 1. Okay. So we're going to get back to what we are trying to do. So I just explained why we are using the index there. So this is what we are doing. We want to get the value 10 out of it, which is why we are splitting on min and taking the growth index. So we're going to do the same thing here. Get the number in the duration of all the movies, and that's what we're doing. So for the movies and the duration column, I am going to apply the split on the text min and get the index 0. So that's going to give me the duration of the movie, and I'm saving it a column called duration name, storing it back. Right. So if I see the duration time, I see all the values of the duration of the movie. I'm also in the end using as type int, so it converts the text number in the text to an actual number. So if I do df movies.info, which we use for looking at the structure also, you can see duration time is int 64, and this is only because we did this as type int, convert that column to integer type. Okay. Now let's plot or look at the distribution of the movies. Looks like everything is in a, and this time we are going to use something like a histogram plot, and the column that we are going to plot on is duration time. Okay, and this histogram shows us this heavy number of movies with around 100 minutes. Okay, and there are some movies with exceptionally high duration time. It's an interesting thing, right? Some movies with close to 600, right? 600 minutes is like 10 hours. So what kind of movies are them? We are going to look at them. Okay. So if we can use the function describe also to look at how some statistics around that. So for example, what is the minimum value? So there's some movies with 0 minutes. Looks like this is a mistake. Okay. There's no point having a movie with 0 minutes. And the max is, like I said, 600, like 10-hour movies. And these are different percentile values. It also gives you mean or the average movie duration, which is 90 minutes. It sounds pretty right. Okay. But in absence of outliers, that value will change. It will be even lesser in absence of these huge movies. Okay, now let's explore the movies which has such a big time, like 400, more than 400 minutes. So let's look at those movies. So these movies are Soothing Surf at Beach for Sleep, Pacific Ocean Waves, Thunderstorm for Sleep, 8 Hours Waves for Sleep, Midnight Water for Sleep, 8 hours, sleep 8 hours, right? Sleep. So these look like not actually movies, but tracks or movies people play to go to sleep, and obviously that is why they are so big. People would want to sleep for 8 hours at least, and maybe 10 hours also. So those are very specific things, and all of them director I can see is Mark Knight, right? So a very interesting thing we figured out in the data set here. So for all the, I'm again looking at the director for all the movies which has greater than 400 minutes. I'm looking at the director, value counts is giving me the distribution again. So it looks like Mark Knight is the most popular director here, creating these kind of movies. There's also James Wellman made two. There's one unknown. Okay. Now what I'm going to do is filter that movie duration, right? Eliminate the outlier. So I'm going to look at only those movies which are less than 400 minutes, right? And if we look at the distribution, this is much more even. No long tail, no big outliers. Okay. Now we saw there's some movies closer to 0 also, right? So let's look at them also, because like I said, looks like some mistake. So what movies are less than 10 minutes? Let's look at them. So there's some comedy, maybe some comedy clips, some kids, maybe some kids clips, some drama, some special interests, and so on. So maybe it makes sense for some of the short form content if that's present, but it can also be possible some duration time is zero, which is what we saw. See, there's some duration time zero for movie project as in Tombstone. Looks like this is test director, tester, and this is what it means. Is it's not a mistake. It's just some test data that was created, and this is not something we want to have in our data set. So what do we do? We remove it. Let's remove it. So what do we do next is first filtered on getting only those movies which are less than 400 minutes. Now we are also filtering on movies which are greater than 10. So we're looking at movie duration which is between 10 to 400 minutes. Okay, and now our curve becomes even more smoother. Now if we do a value counts or do the describe function to get the statistics, we can see the minimum duration of the movie is 10, maximum is 269. The average is still at 90.67, so the average did not change much, mainly because when we had an average of 91, this average was a little higher. We had extremely high outliers, but we also had extremely low outliers also. So they were balancing each other. Too many zeros, too many high values. So when we eliminate both, our distribution remains very similar. So the average does not change much, but the range changes and it's much more smoother. Okay. Now let's say I explore it a little bit on the genre side, the movie duration, and I can use a function called group by. So this is a group by on my old genre, which I did not do any splitting or transformation on. And I calculate the average value on that. So it looks like the comedy, drama, music, video, concert. These things are, more dominating the higher number of values. And kids sports is the lowest. Art, entertainment, drama, horror. These are probably the lowest. But you would probably want to not see something like this. You want to see the genres separately, right? So what we're going to do is to the movies df we want to merge. So this is like SQL joins. So we are doing a left join. So all you need to know if you don't know joins that we are merging two data sets, getting the genre data to our existing movies data set. We want to use it to do that same understanding of duration or every different type of genre. So we're getting those information together so that I can look at it separately. Okay. So I'm getting now genres only for genres who are which are not TV shows. Okay. So for movie genre, because here we got it for a lot of different things. We want to filter only by movie because we are only looking at movie. So for movie genres, I'm seeing what is the you know average uh, time of the movie, which is action movie. So whenever there's one, it means for that value present, which is action present, that means it's an action movie. What is the average duration time? So action movie, the average duration time is 101, and non-action movie is 88. So non-action movie is less in time on an average. Size is the number of movies which are non-action, number of movies which are action, and this is something that we use get by using an aggregate function. Okay. So we are showing different ways of manipulating data, and this is something that we show on one column. Now we're going to extend it to multiple columns and do the same thing, which gives us each of the genres, number of titles, like how many action movies, and what is the average watch duration, right? So it is a way to look at for every genre category, what is the average or the number of titles. For example, fantasy, I have 51 fantasy movies. What is the average duration of the movie, which is 101 minutes. It's an interesting way to look at it. Now, if I want to represent it well with a, so this is not a good way to for me to see, but if I want to represent a good structure, I make it into a data frame. Right now, this looks good. So I can see the genre and again the number of movies in that genre and the average duration time in a structured format. Okay. Now, if I want to put it in a format, graph format, plot it so that I can understand it better, this is much better, which shows me for movies I am looking at international, historic, and romance as the most is the movies which has the highest duration on an average, and that maybe makes sense. So historical and romantic movies maybe has more duration watch to it. For the fitness, it makes sense. Fitness movies can't be, or fitness, it's not in movies. It's probably an instruction course. They're not going to be of long duration. It's like 20 minutes duration on average. It makes sense. And animations are also lower on the duration, the amount of time you watch. So that's good thing. We do the same thing with TV exploration, but this time we are going to not look at minutes because TV had seasons, right? It did not have minutes in it. So we're doing the same thing, not getting into the details of the code, but again the same type of manipulation. We're looking at how much season is there, like what's the distribution that looks like. But this is straightforward because I can just do value count on the categories, and it shows me most of the TV shows have is one season. There's some two season, but it falls off drastically as and when we go to higher number of seasons. So there's only one TV show with 15 seasons, one TV show with 19 seasons, and so on. But this is not ordered correctly. Okay. Uh, so let's look at what is the distribution of TV show with respect to, or the percentage distribution of TV show with respect to. Here we looked at the absolute counts, but now we are going to look at the percentage distribution of TV shows. So 70% is one season, 12% of the TV shows at least have two seasons, and so on. So how do TV show season relate to release year? So we are again doing a plot where we are looking at the number of movie and TV show. We are doing the entire data frame. So we are looking at the number of movies and TV show. We are segregating by hue type again. So movie would have these bars. The orange bars are TV show. You cannot see it well, but the dark ones considered as TV shows. So with the release here, so what it looks like with more recent years, I have more number of movies and TV shows. That does not mean that more TV shows and movies are released in recent years. It just means that Amazon Prime has more number of movies and TV shows which are released in the recent years. Okay, it's good to understand this, insights without any confusion and not make wrong calculation, wrong inferences. So distribution of TV show by release year. So if I look at only for TV show, so I'm doing it for DF shows, and here I am also previously was segregating by type. Here I'm also segregating by season, but then you wouldn't be able to see all the bars because they are overlapping. But again, what it means is that one season shows dominate a lot, and they are most the uh, of the population. So we are using a group by and then creating a data frame, which here it is not ordered. Let's go to the ordered one. So we are going to make an order of it. So once we do the order of it, now once we look at it and order all the years, I can see that the one season ones are growing very fast in numbers when we approach 2021, and it's probably the same for two season ones also. It becomes very high as the year progresses. Three season kind of the same but not too drastic. the rest of the data set is sparse, not too many across any of the years, all the seasons, right? So we can do the same thing, look at the same thing using a heat map, right? So darker the color, the more is the density. That means one season I have more number of TV shows at later years. So these are years, release year 2022, 2021. And that's why the heat map gets darker and darker as we progress. And then the heat map gets also darker for second season. Rest of it is not that much because there's not much density in it. It is mainly dominated by one season or two season shows. Okay. Uh, so we are again doing the same count to show that how many TV shows do we have across one season, two season, across all the years. Okay. So again, highly dominated by one season and two season shows. There's some more, but it tapers very fast in the end. Okay. So if I want to look at some things like what are the 14 season shows that I have, okay, it is going to, so I had shows in 14 season, or three shows which has 14 season. These were the three shows: America's Next Top Model, Paula's Best Dishes, and My Magic Pet Murphy. So I'm filtering the data frame and looking at the title, making that into a list. So now let's look at the TV show duration versus genre. Okay, I am going to again convert the season into the number by doing a split on the space, because the duration has a space in between. And this is how we can split here and get the numbers by referring to the zeroth index, which is the left index, and get the season length. All right, once we have got it, next thing we are going to do is merge with the genre data set. Right, we are going to look at the duration and the genre combination, which is why we are doing that. Once we have done that, then the next thing we are going to do is do some data manipulation. Again, I'm not going to go into the details of that, but what we are going to figure out is for specific TV genres, what does the duration time look like? But here, the duration is the number of seasons and not the number of time for each episode. Okay. Here also it looks like it is highly dominated by historical TV shows like the one we saw in the movies. The duration of the movie was high. Here the duration is the number of total number of seasons that are there, right? And this is the total number of titles or TV shows with that particular genre. Here lowest starts fitness in. So fitness is low in our terms of number of seasons also. It was also low in movies. Art house, music videos and concerts. Okay. Now, if you plot the same thing, we see the same thing. Historical, science fiction, unscripted. They dominate the total number of seasons. Fitness, art house, music videos, and concert. They are at the bottom. Okay. Now let's look at the country. Like I was saying, we look at the country also. It's very, which is why I could not find it then. But it's mainly dominated by United States, some bit of India. Rest of it is minority, right? So these are the total number of movie shows by countries. Blue bar is the movies, TV shows is green bar, right? So United States is dominating it. This is actually after imputation. So we have already done the imputation with United States, which is one of the reason which is dominating so hard. But if we would have done it before also, it would have dominated, which is why this is overrepresented once again, once we have done that. Now we can represent the same thing. Uh, so for movies, we are looking at the top countries or the count of the countries with the movies. It does look like United States have huge outliers. That means so we are looking at the duration of the movie. Okay. So United States have these movies which very high duration. The white noise or the sleep movies that we are talking about, They're mainly present in the United States. The other ones do not have that long. But you see India. So box plots is a way to represent data again. Or it's a different type of plot where this middle line is the median, and this shows kind of the range of the data, and this is the usual range of the data. This box is the usual range. So India on an average, so what you need to take away from this is India on an average has movies of higher duration. Okay, but it does not have crazy outliers. A movie with 10, 8 hours. That is United States, which are dominating it. But United States on an average has on the lower side, and it also have lower outliers, like some tests. So those are 0 minute movies. So there's some test data, right? Here we have some combined things, which is United Kingdom, United States. But Canada, United Kingdom, they have lower range. They also do not have crazy outliers. Right? Now this is known as violin plot. It pretty much represents the same thing. Duration of the movies. Now this is the tail that shows the outliers, but this again shows the distribution. Or the more it is stretched, the more is the range of that particular plot. For this, the duration is a higher the range of 10 minutes to 600 minutes. United States has a very high range, but because this range is unusual, some of it is outliers. And this is just another way of seeing box plots. Now, the other thing is that once we have done all the exploration, let's do something interesting. So this is going to be the most interesting that I'm going to see today's session. We are going to do a search on the titles and search for particular movies based on something that I want to do. And here I'm going to use embeddings. Okay, so think of it like when a user is searching for a particular movie, what kind of recommendations would Amazon Prime give, right? So this recommendation I'm going to make based on the description of the movie. So let's see how the movie description looks like. The small fishing village with some description of the movie. All right. Now that we have taken a look at it, I'm going to get the description length as well by doing a split on the space, which will give me individual words. And I'm going to do a length of the number of words that were created. That gives me the description length. So I have the description, I have the description length. Then if I do some exploration on the description length, I can see movie and TV shows on an average have same description length, but movie has a lot of outliers. Like some movies with a lot of description. Some TV shows also have some outliers with description, but on an average, the middle part looks the same. So they have a similar structure to it. Okay. Now we are going to use embeddings. Like I said, computers do not understand text, so we have to convert text to numbers. Embedding is a very intelligent way of representing text. Embeddings have the understanding of the text data embedded. For example, my name is Arnab. So if I say my name is Arnab, if I do a one hot encoding on that, it's going to create calls of ones and zeros. So it's going to say whether that number the text I is present or not, am is present, Arnav is present or not. It does not relay a lot of information, but embeddings in itself is a very dense representation with continuous numerical representation. The same idea of I am Arnab is represented very well in text data, which is embedding. Again, it's a separate topic in itself. We'll take a different class, but we are going to use a sentence transformer to convert text to embeddings, right? So what we are going to do next is, so this is the encoding process where we are going to take the description and create them into embeddings. So now for every single movie's description, that is a text, I've created embedding. Embedding is a vector or dense representation, a numerical representation, which has enriched information. I've created that into an embedding. Okay. Now is my embedding shape. So these are the number of descriptions that I have. So this is for movie. That's why those are the number of movies. And 768 is the number of columns or embeddings. Like one hot encoding had n columns, which is n number of categories. Embeddings would have, this embedding has 768 shape. This is because this is predefined for the model that I'm using. Now the interesting thing is to compare text with text. I need to convert both the text to embedding. So movie description I've converted to embedding already. Now, if I have a query, let's say movies about World War II, I want to find movies which are about World War II. I need to convert this text also to embedding. So, which is what I'm doing, encoding users query to embedding. So now both of the descriptions are uh, converted to embedding, and the user's query also converted to embedding. Now these are numbers, right? We can calculate the distance from one embedding to other. Lower the distance, the closer they are to each other, and that's how we are going to find it. Here we are going to use a thing called cosine similarity. This is a way to match text data with the right distance, and that's what we are doing. So to the existing embedding of all the documents, which is the descriptions, I'm matching the user query. So what this means is movies about World War II will be matched with all the descriptions to see which descriptions match with this particular query, or the distance from the description is close to this particular query. I'm going to plot it in a similarity array. Okay, we are going to look at the plot later, but let's look at the results. How well the matching happened. So I did movies about World War II and look at the results it has given me. Okay, so it gives title chosen. So Hardwick stars Hungarian citizen whose courage alerts course of World War II. Okay, this is a World War II movie. Then title Archive of World War II. This is another World War II movie. Saints and Soldiers. This is also World War II movie. Another World War II movie. This is a very good match, very good search, right? Now there are other simple forms also. Can you search by, you know, just try and find World War II text? You can, but think about the variability here. The title has World War II as 2, here 2 as numeric number, there's WW2, then there's World War numeric 2, right? Think about the variability, and this is for only one query. How are you going to make it into a system, right? It's very difficult to do when you are doing a hard-coded text matching. But embedding solves that problem because it understands the text and represents in numerical form, which we can use for matching. So that's a great thing we do. All right. Now, and that's actually one of the state-of-the-art model. We use this in RAG architecture. This is used in GPTs and LLMs on finding the best response for your queries. Again, those are very deep topics to be handled in separate sessions. We're just going to touch it. The final topic for today is uh, top, uh, we are going to look at topic modeling, and the topic modeling is nothing but if I want to figure out what are the topics or the movies that I have. So if I want to find from the descriptions, not from the movie genres or movie titles, from the descriptions, it has a lot of text, right? If I want to find out what kind of movies are in there, without understanding or visualizing the separate words, which wouldn't really tell much. But if someone can read all the text of the description and then tell me what kind of movies are in there, what kind of similar types of movies, what are the topics, and so on. Topic modeling is a good way to understand and also use it in models. So things that we are going to use transformers again, image transformers to create embeddings. You may have to reduce the dimensionality of the embeddings this time. Last time for the embeddings, we had dimensions of 768 columns, right? We can reduce the dimensions by using UMAP. There are other, uh, you know, uh, algorithms also to reduce the dimensions, such as TCA, TSNE, and so on. Then we do cluster. Clustering means grouping similar objects together. Here we are going to group similar type of movie descriptions and create synergy within them and represent them in a similar fashion. So count vectorizes a word to create tokens for our text data. And then TF-IDF transformer I have. Think of this like when I have two sentences like, my name is Arnab, uh, and someone says my name is Ajay. Here, my name is are both similar text, but the difference between both are text and what has the most amount of meaning is our name, which is Arnab and Ajay, right? So TF-IDF finds those areas which has most amount of information and gives them higher rating. So once I have all these parameters, I pass it to my model bot topic, which is my topic modeling model that I use today. And what I'm going to do is find topics to understand the data, but then not getting into the tableau representation. Let's look at the graphical representation of the topics. That would give us very good understanding of what topic modeling did. So within the spectrum, you can see it created all these clusters, and these clusters are, let's look at it. Okay, topic 7 has rock band music pop album, and at the same time we have topic 3. Topic 27 has yoga, stress guided, reduced. Right? Topic 20 has sleep video, REM, location, sounds. They have some similarities within them, but each of the topic also has separate, flavor to it. And if I look at it in a separate chart, I can see that topic 0, there's love story, life, village, India. This definitely looks like an Indian story. Okay. And rest of the topics also have lot of other interesting stuff to it, and looks like movies are, and these topics are around a lot of movies, clusters of movies. So this topic 3, special comedy, stand comedy and art, this looks like some movies or TV shows around stand-up comedy, right? That's how it is represented. So topic modeling does this, which is creates clusters of similar topics from the description, and we are seeing that in multiple different visual representation. The final one is similarity matrix, and here I'm seeing what is the similarity between topics. And if I look at uh, let's say, so the horizontal will always be the darkest. That means the biggest synergy is there. That because horizontal matches with itself. So love story, love life matches with itself and creates the darkest space. But other dark space means there's synergy between or similarity between those topics as well. And those topics you would see being clustered around the same space. All right, so that is what it is. And who had something to take away from today's session and it was enjoyable for you. Thank you so much once again. And I would give it back to Akshay to continue. And I'm also happy to answer any questions if you have the time.
Thanks, Arnab, for that insightful session uh, on the Prime on Amazon Prime dataset. So, learners, I do hope that you got something out of this session. Had some of your queries answered, and you learned something new. If you have any question for Arnab, maybe you can shoot it now, and then uh, we can move ahead. So, someone has asked, can we get the notebook? So, we have shared that GitHub repository link. You can refer to that. It has been shared in the chat, and I'll also type it out here. Yeah. Okay, so I think there are no questions. So maybe we can. So yeah, thanks a lot, Arnab, and maybe I can now. Uh, if you guys would like to stay back, I also do have some things to present regarding data science, machine learning, and how you can up level in this domain. Yeah. So I hope my screen is visible.
Yeah, I can see it.
Okay. Yeah. So so essentially, what we saw with the Amazon Prime data set was a complete data processing and data exploration exercise, right? Wherein we explored the data set, like right in its raw form, right, and see how your and you saw how you need to perform certain actions in order to get it into an analyzable state, right? And then we did various analysis on on different columns and got all these insights, and we ended with even doing some analysis for text, for text data, big descriptions, right? And as Arnab had mentioned, that everything that you feed for any data science task, right, all of it has to be in numbers. And that is sort of where we are right now, right? That big descriptions, big text, like those things weren't possible, but since the last say 1.5 2 years, right, we have gotten a lot ahead in text processing and text analytics with generative AI and LLMs, right? So we at IK also recognize that. And uh, sorry, just a second. Yeah. And like if you take a look at the market also, right, that despite the market conditions being a lot up down in the last year, the demand and the the need for AI ML job roles has been still strong, right? So if you take a look at this message from Intuit, when they were very recently when they were laying off 1,800 employees, as you see, Intuit will simultaneously hire the same number of new workers as a part of restructuring effort focused on AI. Even the traditional tech roles that we have, right, are evolving more to require AI ML expertise. The tech expertise is still needed, but you also sort of need some AI ML expertise as well, because if you take a look at the whole generative AI industry also, and what businesses are doing with that is they are taking all these very well functioning foundational models, and they're sort of introducing it into their systems in their architecture. So a lot of generative AI itself has largely become, say, software engineering, right? uh, so yeah, that's why machine learning, data science, generative AI are very very important still, and they will continue to be important for quite a while. uh, then yeah, there is a major question that why should I upscale or switch to machine learning, data science, generative AI, right? So like I said, that it is still prevalent, right? And the companies are still in the process of integrating generative AI regularly, and mostly planning to increase their AI investments, right? Because a lot of these solutions are now possible with generative AI, and it is going to significantly sort of disrupt or many of the industries. And though there has been some time that companies have taken to adopt it very formally, right, well, without any data issues, still informally, if you see across industries, across job functions, you would see people utilizing AI LLMs to some extent, at least in their current job roles, uh, right? And with this respect, interview Kickstart sort of offers two uh, major switch up programs, right? The first one being the machine learning switch up course, where we focus on we focus on the outcome of becoming a company oriented machine learning engineer, right? So 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 because machine learning, data science are are eternally important, and with generative AI and the demand for these skills becoming even more, they have become fundamentally paramount in the data industry, right? So what this curriculum offers you, is a 12 plus 2 month program, wherein you start with the foundations for Python, SQL, some database modeling, and spend some time on also the essential math and classical ML, where we go through the uh, through probability data distribution, some classical machine learning algorithms, EDA, like Arnab had just taught EDA, data processing, and then just putting these into machine learning models like regression classification, right? And the final and after that, the main part of the course, like half of the more than half of the course focuses on state of the art models and modern ML architectures, right? So you will get to understand deep learning, computer vision in and out, uh, the architecture, the implementation, and through these three: natural language processing, modern ML architectures, and generative AI, right? Which is a large part of the program. You will, also get to know all the state of the art models and how you actually implement them in production along with ML ops, right? And then the final 2 months sort of focuses on machine learning interview prep, where you go through some standard data structures, algorithms, software system designs, ML system design, right, which are traditionally asked in machine learning engineering interviews. And you also have some you know cla- some services for soft skills as well, which will help you really optimize your job search. So there's the machine learning switcher program, to become a company oriented machine learning engineer. But we do also have a data science program, right, wherein uh, we maybe not focus too much on the deep learning aspect, but data science, like I said, also is quite important, and the demand for data scientists is still stays a lot stable, right? And it is increasing, right? So here we focus more on some of the traditional methods, right? So if you take a look at a lot of these service companies and captives, financial institutions, right, they do have a very very large demand for data scientists. And the reason is these larger companies, these legacy companies, cannot traditionally very easily integrate generative AI as well into say their existing systems, right? And with the volume of data that these companies have and the kind of outputs they need, the classical ML and the more traditional data science things like classical ML, and then visualization, big data, dealing with large amounts of data, uh, and weekly reporting, everything, all of this is very very important. And you will see like a huge demand for data science there. So in the data scientist curriculum, we focus a little more on Python and SQL, as that is fundamental. And if you take a look, if you compare it with the ML curriculum, here you see we spend about 3.5 months on essential maths and classical ML. Here we spend more than 5 months on it, going through all the various statistical methods and algorithms, and even covering some of the things that may not be a part of the machine learning program, right? Things like time series and statistics, right? And finally, so the last 5 months is focused on giving good foundational knowledge of deep learning and natural language processing, because that is also sometimes expected in some data science roles. But then we largely focus on big data, PySpark, visualization with these UI tools such as Power BI, and focusing on data so sorry, and focusing on data storytelling and advanced visualizations. Sorry, just give me 1 second. Yeah. And again, we end with 2 months of DS interview prep, uh, wherein you will learn, you know, the standard stuff, that is asked in some FANG interviews, right? So for data scientists and machine learning engineers. And just to give you an idea about the kind of hands-on that you will get, right? So the programs will have mini projects on many of these topics, and then we end with final capstone project in both the programs. And the kind of capstone projects we have, right, will give you a very good idea of you know the kind of portfolio you need to build, and the kind of proof of concepts, POCs, you need to have in your resume in order to land these jobs. So these are some of the capstone projects from both our data science and machine learning program. You have the style lens fashion finder, where you know use that which is similar to a Google lens, right, where you can capture a photo of any, say, clothing item, and style lenses advanced ML algorithm basically uses a lot of CV and and this image generation and these image models to actually classify and build a comprehensive wardrobe exploration tool. Then you have something like bin sense AI, inventory vision system, wherein there's more of a uh, business industry product, wherein uh, this product aims to sort of organize the inventory management, right, similar to what Amazon's warehouse technologies have. So here again, the idea is to build an advanced computer vision system to identify uh, the items in the warehouse, and being able to keep a track of all those inventories in real time without any manual intervention, right. Then you have vision assist, lost and found AI, which is again similar uh, uh, image based capstone project. uh, then say you have the resume coach, which is an AI powered job application coach, wherein again it's similar to say LinkedIn's resume assistant, right, that you give in your resume, and ba- and based on some job descriptions data that you have, it can actually customize and create a personalized application for you, right, and give you some insights on how you can optimize your job search. MediWatch is a is a project focusing heavily on ML ops, right, wherein in the healthcare industry, firstly you need like the healthcare industry is say also where you have more classical, traditional classical ML and data science tasks, right. So predictive analytics, machine learning is also very important. So this project essentially utilizes the patient data to just predict the readmission risks, and again enabling proactive care, because a lot of this will be done in real time, and this project says very very ML ops heavy, while some of the projects were say Gen AI heavy, you will also have ML ops heavy projects. And then a shop talk, which is again a similar LLM based project. So if you take a look at the end project, the end game that you will do at the end of the DS or ML program, you will be able to sort of build actual actual end to end POCs with all of these comprehensive project. That is the level where you will get to with the interview kickstart program, right. I also have some more projects listed where you have this review some AI. So a lot of you might have seen these Amazon summaries, right? Like any of you who shop online, like would have seen that. So you'll also be able to create a similar tool wherein you'll take large, very very large volumes of Amazon reviews and be able to identify the relevant tags from them and build a concise summaries around each of those products, right. And talking about the end of the program, obviously you will get a lot of career support services in the form of LinkedIn profile building, professional branding, resume optimization, all these soft skills, as well as AMA sessions, mentorship, and some job application strategies, which will also help you brush up and your technical skills, and you know like help you optimize your job transition. And these are some of the feedbacks from our past students. So yeah, if you have any questions around these, or any around my presentation, or anything that Arnab may have covered, please feel free to shoot. Okay, I don't think that there are any more questions. uh, so yeah, you can so yeah, we can end the session here, and if you have any more questions, you can reach out to your PA. So thanks a lot for joining in on a Sunday morning, and staying with us throughout. We know we extended the session by about 25 minutes, but we really do hope that you uh, got something out of this session. And thank you, learners. Thank you, Arnab. Thanks, Swati.
Thank you. Bye.
Bye bye. Have a great day.